Hi, my name is Maria and I'm a product manager at Edinburgh Instruments. In this video, we will show you how to acquire rapid transient absorption spectra using the LP980's multi-channel detector. The LP980 is our transient absorption spectrometer, and in this case is configured with two detectors: a photomultiplier tube for kinetic single-channel acquisition and an ICCD camera for multi-channel spectral acquisition. The PMT is a point detector, so it detects transient absorption at a single wavelength. It provides a TA decay with high time resolution in a single laser shot. The wavelength can be scanned with the monochromator to obtain spectral information. While this is a very common approach to obtain TA spectra, it is time-consuming. The ICCD is an array detector. In this case, a spectrograph port with a large aperture is used, so the full spectrum is imaged onto the ICCD at once. You can obtain the full spectrum at the selected delay in a single shot. The ICCD acquisition can be delayed with respect to the pump pulse to obtain kinetic information. Obtaining the full TA spectrum at once saves significant time compared to traditional PMT-based detection. On the left, we can see a spectrum obtained with the PMT, scanning the monochromator wavelength and recording a decay for each laser shot. This took 1 hour to acquire. On the right, we can see the same spectrum acquired with the ICCD in under 30 seconds. Besides saving experiment time, the ICCD is very useful if your sample suffers from photobleaching. This means that the sample is permanently damaged by the excitation light, and its concentration decreases as the experiment progresses. In single-channel TA, the concentration varies during the wavelength sweep, and this leads to an incorrect spectrum. In some cases, the signal can disappear completely before the end of the experiment. Biomolecules are very sensitive to photobleaching, so the ICCD becomes invaluable in these applications. These are TA spectra from photoactive yellow protein acquired with the ICCD at different delays. Each spectrum takes just a few shots, so you can capture the full dynamics without photobleaching. Now let's see how the experiment works. We will use the L900 software, which controls the instrument and analyzes the data. Spectral transient absorption is easy with the LP980 software, L900. In this case, we're measuring a ruthenium polypyridine complex, and we will average 4 spectra, that is 4 laser shots. The ICCD gate switches the acquisition on and off, defining a time window where data is taken. We can control its delay and its width. The gate delay shifts the start of the acquisition with respect to the pump laser pulse. The gate width defines the length of the acquisition. A longer integration time gives us better signal-to-noise ratio, but we lose time resolution. On starting the measurement, we will see the spectrum of the probe light through the sample in green and the spectrum with the pump laser on in magenta. The software averages all the laser shots and displays the results as a delta OD transient absorption spectrum. We can map the TA spectrum as a function of time with the delay map option. In this case, we define the number of delays to acquire, as well as the step size. And we select the number of averages for the required signal-to-noise ratio. As previously, the software displays the probe-only background and the pump and probe spectra as they are acquired. The ICCD gate delay is scanned, and a transient absorption spectrum is acquired for each delay. Once finished, a map of the transient spectrum as a function of time is displayed. As we've demonstrated, the ICCD provides rapid, high-quality transient absorption spectra, and it's a game changer if you're working with photobleaching samples. Thank you for watching. To learn more about spectroscopy, visit the link in the description and subscribe to our channel.